Welcome to our guide on how to actually build an AI agent. We are moving past the hype of writing clever prompts and getting into the engineering required to take an AI system from a simple goal definition all the way to a robust production deployment. First, we must address the graveyard of AI projects. Most demos look like a magic box that just works, but reality is messy. Production failure usually isn't about intelligence, it's about architecture, handling API failures, data loss, and undefined goals within a complex system. This begins with Phase 1, precision goal setting. A vague goal, like build an email assistant, is a recipe for failure. To succeed, you need a best goal that is actionable and metric-driven, such as classifying inbound emails into specific categories and auto-drafting replies for a subset of them. Once the goal is set, we design the workflow. Agents aren't magic, they follow deterministic logic patterns. Whether it's a router that directs tasks, a planner that breaks them down, a RAG system for retrieval, or a background monitor, you need to map the flow explicitly. Crucially, for high-stakes actions, we implement a human-in-the-loop architecture. An agent can analyze and draft, but for financial transactions or external communications, a HITL gate serves as a necessary safety valve before execution. Moving to Phase 2, we look at the model hierarchy. You don't need the most expensive model for every task. Efficient architecture mixes models. Use small, fast models for routing, mid-tier models for drafting, and heavy reasoning models only for complex logic and coding. An agent is just a chatbot until you give it hands. This is tool integration. Using a hub-and-spoke model, the agent connects to your email, CRM, databases, and ERP systems, producing actual digital artifacts like sent emails or updated records. Next is memory architecture. A large context window is not the same as memory. A robust system uses layers: RAM for the current session, episodic memory to log past interactions, and semantic memory as a structured knowledge base or encyclopedia. To feed that brain effectively, we practice context engineering. We don't just dump raw data into the prompt. We filter, summarize, and use sliding windows to funnel noise down into a clean context, ensuring the highest signal-to-noise ratio for the model. In Phase 3, we select the tech stack based on organizational maturity. Level 1 might use low-code tools like N8N for prototyping, while Level 3 requires software engineers using frameworks like LangChain or custom Python for enterprise-grade production. But does it work? Testing and evaluation are critical because working once doesn't mean working always. You need a health monitor to track functional success rates, safety violations, and drift to ensure the system doesn't degrade silently. We also have to solve the cost equation. AI is unsustainable if you don't measure it. By calculating model costs, context size, and tool calls against the success rate, we can prove the ROI of an AI agent, effectively costing cents per task versus expensive human consultation. Before launch, we apply governance and control layers. Just like a human employee, an AI agent needs a pre-flight checklist, defined ownership, success KPIs, strict access boundaries, and comprehensive audit logs for accountability. This brings us to the unified framework. This comprehensive architecture spans 3 phases: define, architect, and operationalize. It emphasizes that agents are not just prompts or demos, they are fully engineered systems. Now your turn. Use this workshop canvas to design your agent immediately. Fill in the job definition, sketch the workflow, list the required tools and memory needs, and decide on your model hierarchy and success metrics. Thank you for joining this deep dive, brought to you by Imbilla.ai, the studio for AI-powered consulting. We are here to help you learn, build, and transform your business with real AI systems.